Hello there. I feel like going on a journey today. So we're going to start with a regular pentagon and construct diagonals, and you can see that it creates a smaller pentagon in here, and I'm going to try to figure out the ratio of this side to one of the original sides, effectively the scale factor. Okay, let's label the points. Okay, there it is, regular, and let's label the other points too. Okay, because it's regular, we know several things. We know that that's congruent to that, congruent to that, congruent to that, congruent to that. And we also know some things about the angles too. So the big angle here, the big angle on this outside, we can figure out what that is. So each of those angles has to be 108. Then we can start thinking about, well, how does that split this area up inside of here? Like what portion goes there, there, and there? Well, each one of these diagonals creates a triangle here, and that's an isosceles triangle, so the base angles over here and here, those base angles have to be congruent. So each of those is going to be 36 degrees. So we got 36 degrees there, 36 degrees there. Now there's a whole argument here where, well, this triangle, you got side, angle, side. This triangle over here, you're going to have side, 108 again, side. This one, this one, this one. So all of these diagonals have to be the same length. All of these little angles throughout the whole thing have to be 36. And then we can say if 36 is here and 36 is here, 108 minus 36 minus 36 is 36. So there's a little 36 in there too. So each of these angles is being trisected. But let's figure out some lengths. So we're going to call this side S. We'll call this S. Those are those lengths. And we're going to call this side here, that's one of the diagonals. Let's call that big D. And I want to know what big D is. Well, it's got a 108 degree angle opening up to it, and this 36 degree angle is opening up to just a single side. So let's write out law of sines there and multiply through. So I know that there's this S involved, but this part here, I can divide those two things. And I get about S times 1.618, etc. And yes, Peter, this is the golden ratio. That is phi. Okay, so I got this big length down here. That D is equal to this length times the golden ratio, 1.618. Now, for this little part here, well, we have these portions over on either side. I'll call that L for little portion. Okay, the triangle here, EPA, that's an isosceles triangle, so we also see that L over here. And that triangle is actually congruent to this triangle over on this side too. So both of those are L's. And I want to figure out what the angles are involved. That triangle has a 36 degree angle there and there, so that actually tells us that this angle has to be 108. There's 108 too. So it's kind of interesting. This little blue triangle, all of these little triangles here, they're actually similar to these larger pink triangles. Alright, now I'm going to get what L is. So connecting opposites on this one, L over sine 36 is equal to S over sine 108. So we get that that little L is equal to S, the original side here, times about 0.618 other stuff, and it turns out that this number is actually 1 over the golden ratio. So we wanted the original sides here of the smaller regular pentagon. It's a little bit of work to convince yourself that they're all congruent sides, but we have all these similar triangles. So I want to get this length there. I was going to call it S for small, but I've already used S for side, so I'll call it T for the tiny one. Tiny one is going to equal D times 2L. And so we get that that is S times the golden ratio, or phi, minus 2 times S the golden ratio. Let's factor out the S. So that's S times the golden ratio minus 2 over the golden ratio, or that's about S times, what is that, 0.38196 other stuff. And the amazing thing here, so that's the scalar across all of that stuff. This number here, that's actually T is actually S times 1 over the golden ratio squared. If you type that in and square it, you'll get that. That may require a different video to show. Okay, thanks for watching. Character and Scholarship for Life.